Hello, classmates. Today, we are going to learn the case of ultrasonic testing. Through the analysis of this case, I hope that everyone can use the theoretical knowledge of ultrasonic testing that they have learned to plan the testing process as a whole. Become familiar with some testing points that must be known and learn to analyze the problems encountered in the actual testing process. The following is an ultrasonic inspection of the butt welds of bridge plates by a testing company. The executive standard is MB/T47013-2015 and the detection technology level is B. The material of the test object is Q345D and the welding method is MIG/MAG welding. After receiving the task, the inspector should complete the following tasks according to the process. 1. Test preparation. Test preparation mainly includes 3 tasks. 1. Familiar with test object, material, welding method, and specification. The purpose of analyzing materials and welding methods is to predict which defects may appear in the inspection object, what their distribution characteristics are, and where dangerous defects are most likely to appear. The material Q345D in this task has a carbon equivalent of 0.345% to 0.491% and a yield point of 343 MPa. The material has less alloy content and better weldability. It can be seen that under normal welding conditions, the quality of welded joints is easy to guarantee. 2. Research implementation standards. In accordance with the provisions of the B level in the implementation standard NB/T47013-2015, the detection of the transverse defects. A key-value probe and single-sided and double-sided scanning should generally be carried out. 3. Compile ultrasonic testing process regulations and operating instructions, providing guidance documents for the subsequent implementation of ultrasonic testing. 2. Inspection points. 1. Select hardware facilities such as instruments and probes. The performance of the ultrasonic detector and probe shall comply with MB/T47013-2015 and shall be within the qualification period. For example, the horizontal linearity error of the instrument is not more than 1%. The vertical linearity error is not more than 5% of the probe. The diameter of the round wafer or the length of any side of the square wafer is not more than 40 mm, etc. Determine the frequency of the oblique probe as 2.5 MHz and K as 2.5 in accordance with Table 25 of the Executive Standard. Such provisions should be clearly specified in the process, regulations, and operating instructions. 2. Determine the type of test block. The function of the test block is mainly used to determine the detection sensitivity. Select the K value and frequency parameters according to the provisions in Table 25 of the Executive Standard. At the same time, Article 4.2.5.4.2 stimulates that when using an oblique probe, the incident point, frontier distance, and refraction angle K value should be measured before testing. The oblique probe CSK-IA test block must be used to determine the K value of the inclined probe, and the CSK-IIA test block is also used to determine the detection sensitivity. Therefore, CSK-IA and CSK-IIA test blocks are necessary for this detection task. 3. Workpiece. The standard stimulates that the surface roughness of the workpiece in the scanning area of the probe should not be greater than Ra 25 microns. 3. Inspection implementation. During the formal implementation of ultrasonic inspection, appropriate measures should be taken to ensure that the surface roughness of the workpiece in the scanning area should not be greater than Ra 25 microns, such as cleaning up, splashes, etc., and select ultrasonic detectors, probes, task blocks, and components in strict accordance with the operating instructions. In addition, as a test implementer, you should also be familiar with and complete the following tasks. 1. Inspection area. The inspection area is the area that must be inspected in the workpiece. According to the provisions of Article 6.3.4.2 of the Standard, the inspection area is as shown in the figure. 2. Probe moving area. Probe moving area refers to the width of the probe's skimming range on the workpiece surface. According to the provisions in Appendix N of the Standard, the workpiece should be detected by the single reflection method, and the width of the probe moving area is L is equal to 1.25 p. Therefore, the width of the probe movement area according to the selected probe is shown in the figure. 3. Instrument adjustment. The standard stipulates that before using the oblique probe, the incident point and the refraction angle of the oblique probe must be measured, that is, the K value. Therefore, these parameters should be measured on the CSK-IA test block before testing. Theoretically speaking, there are 3 adjustment methods for the baseline for the instrument, which are according to the depth, according to the level, and according to the sound path. The first 2 are commonly used. When the thickness of the workpiece is thin, it is generally adjusted horizontally. When the thickness of the workpiece is thick, it is generally adjusted according to the depth. Either way, a suitable scan ratio should cause the farthest defect echo in the workpiece to appear around 80% of the horizontal scale of the display. According to this, the welded joint can choose to adjust the time-based line according to the depth of 1:10. 4. Draw the DAC curve. The range of the DAC curve should cover the depth range of 80 mm for the one reflection method. According to Table 27 in the standard, the evaluation line is phi2 is multiplied by 20 minus 18 dB. The quantitative line is phi2 is multiplied by 40 minus 12 dB, and the waste line is phi2 is multiplied by 40 minus 4 dB. 5. Scan. According to 6.3.8.4.5 of the standard, the scanning sensitivity should not be lower than the sensitivity of the evaluation line, and the height of the evaluation line at the maximum sound pass within the detection range should not be lower than 20% of the full scale of the fluorescent screen. 6.3.8.4.6 stimulates that when detecting and evaluating transverse defects, the sensitivity of each line should be increased by 6 dB. Therefore, the scanning sensitivity can be taken as phi2 is multiplied by 40 minus 24 dB, and the lateral defect sensitivity can be taken as phi2 is multiplied by 40 minus 30 dB. Defects are found by zigzag scanning, and oblique parallel scanning is used when detecting transverse defects. Note that it should be carried out from the opposite two directions. When a defect is found, the highest echo of the defect can be found by 4 basic methods: front and rear, left and right, corner and surround. According to the above-mentioned operations, during the inspection process, pseudo-defect signals near the surface are often found, and the reasons for their occurrence are analyzed seriatically. First, through theoretical calculation, the upper half diffusion angle of the shear wave of the K2 oblique probe is about 6 degrees, and the lower half diffusion angle is about 5 degrees. The sound wave at the certain angle set to 59 degrees of the diffusion angle sound beam is just as the point A may be undercut or weld groove, and the echo signal is stronger. At this time, the actual depth of the signal is H is equal to 80 mm, and the second pass is S is equal to 8 splash cosine 59 is equals to 153.8 millimeters. But the instrument displays the depth calculated by 63 degrees, which is H1 is equals to S multiplied by cosine 63 is equals to 69.8 millimeters, so the indicated depth is 10.2 millimeters smaller than the actual depth of point A, and this signal is mistaken for the defect below the surface. Further analysis shows that in this case, the echo depth indication decreases with the increase of the probe angle and plate thickness. The generation of this signal and the amount of reflection mainly depends on the size, direction, and shape of the effective reflection surface of the lower diffused wave or the excess height. It can be seen that in the actual ultrasonic inspection, various possible factors must be comprehensively considered in judging the defect signals. This is especially true when there is clear non-compliance with the pre-test pre-analysis or when there is suspicion. Usually, we can draw on the paper, theoretically analyze the possibility of its existence, and make full use of theory to guide practice. In addition, in this case, it is necessary to carefully observe the shape of the wheel, replace the probe, double-sided and double-sided inspection, grant the weld height and undercut if necessary, and even add other non-destructive testing methods to avoid misjudgment. Well, this test case is analyzed here. Thank you for your watching.